Hello. Can you hear me?
Yes, I can hear you.
Okay, let's try. So which question have you solved out of these four? Which
Solved this
question?
one. First one.
Okay.
Find the highest altitude.
Okay, so let's try the second one.
So this is a graph-based problem, but I'm not sure how we can solve this one. Like,
Okay, let's try. So can you explain the question?
there are multiples. I will take the example, the first example. So n is the number of languages. So here n is 2. So we have two languages, 1 and 2. And in the languages array, it is the set which tells us the languages which a particular user, the ith user knows, right? So here there are three elements. So we can say there are three persons, 1, 2, and 3. First person knows language 1, the second person knows language 2, and the third person knows language 1 and 2.
Okay.
And there is also one friendship, which is a 2D array, which denotes the friendship between two people. So 1 and 2 are friends, 1 and 3 are friends, 2 and 3 are friends.
Okay.
Uh, so now we have to find,
Okay,
we
I
have to
got it.
choose one language.
So it is like the number of connected components in a graph, something like that.
Yes, yes.
Okay.
Uh,
So we have n language
think-
from n to n, and language I is the set of the language. Then the ith user knows. Friendship I is, so this is the like age between the node. So okay, so I think we have to union, right? So if a user 1 and user 2 know a language, okay, so everyone can speak to each other.
If they are friends.
Okay.
Like we have to choose one language and teach it to some users so that everyone can communicate with each other.
Okay, yeah. So it's like that thing, and okay. So we have to union or something like that and find the number of connected component. Okay. So let's take this example, n equal to 2. So it's like, so if we take this example, and so and this is the array of language, right? Yes. So array of language. So we have language 0, 1, and 2, right?
Language 1 and 2.
Oh, language 1 and 2, not 0.
Yes. There are n languages numbered 1
to n. Oh, sorry. Language is like 1 to n. So language is
1 and 2.
1 and 2, and users are
3.
Users are 0, 1, 2. No,
1, 2, 3.
1, 2,
1,
3.
2, 3.
And how
Yes.
many users you will know? How would you know that how many users are there?
Like, finding the length of the languages array.
Okay, so like
because it is not
language
given
array.
otherwise.
Oh, it's like so the number of language that I know, like user 1 knows language 1, user 2 knows language 2, and user 3 knows language 1 and 2. Okay. And we have the friendship is like 1 and 2 are friend, 1 and 3 are friend, and 2 and 3 are friend. So we can make users as a graph. Okay. And we have the friendship will be the node. And now we have to combine those users. So in this case, 1 and 2 are friend. So they can communicate or what?
No, they do not know the because the
Okay.
first user knows only language 1 and the second knows only language 2.
Two.
There should be one common language between them to communicate.
Okay. So we need to teach them either language 1 or 2.
Yes.
Okay. And user 3 can speak all the language. And so,
Yes.
we need to teach one language.
Yes.
Okay, got it. So, okay, and let's take the second example. So we have 2, 1, 3, 1, 2, and 3, 4 users, and 3 language, and Francis are like this. So user 1 and 4. So in this case, user 1 can speak language 2, and user 4 can speak language 3. So we have to teach
No.
either one, something like that, like either we need to teach one other language 3.
The language 3 or language we can teach the person for the language 2.
Teach, okay, teach language 2. Okay. and what else? 1, 4, and then 1 and 2. So 1 speak 2 and 2 speak 1, 3. So we need to also teach. Do you need to find the minimum number of language to teach?
Yes, minimum number.
Or minimum number of users?
Return the
you need to
minimum
teach?
number of users.
Okay, you can choose one language and teach it to some users. Okay, so we can
Yes.
choose one language and teach it to some users so that all friends can communicate with each other. Okay.
Yes.
So what I'm thinking is, so in this case, in the second case, how many? So user 1 can speak language 2, and 1 and 2 are friends, 3 and 4 are friends, and 2 and 3 are friends. So like 1 and 4 are friends, and 1 and 2 are friends. So they're,
Yes.
and then 3 and 4 are friends. So all are friends.
No, so it is not transitive.
Okay.
Friendship is not transitive.
Okay.
It is written there. Like you can go. Yeah. Note that the friendships are not transitive.
So okay. So if they are friend, then they should speak one common language, right?
Maybe like suppose 1 and 2 can communicate with language 3, and then 2 and 3 can communicate with language 1, right? So they don't have to know the previous language.
Okay. So you're saying 1 and 4 are friend, and 1 speak language 4, and 4 speak language 3. So we need to
3.
teach
Yes.
either a language to either 1 and 4, or like one or 4. Like
Yes.
1 or 4 need to teach one language. Okay, and let's see, 1 and 2 are friend. So, and 1 speak 2, and 2 speak 1 and 3.
1 and 3. Yes.
So 1 and 2 need to teach one language. One language. Okay. And 3 and 4 are friends, and 3 speaks 1, 2, and 4 speaks 3. So 3 and 4 they need to speak one language. Teach one language. Okay. And now 2 and 3 are friend, and 2 speaks 1 and 3, and 3 speaks
There
1
is one
and 2.
common language.
So we don't need to do about something about that. So 1 and 4
Yes.
need to teach one language, 1 and 2 need to teach one language, and 3 or 4 need to teach one language. So we need to teach 1, 2, and 3. No, 1, 2, 3, 4. The answer should be what? If we teach one a language and
Oh, no, we have to choose one particular language.
okay, so if we choose language 3, so
Yes.
if we choose language 3, so like it will be 2, 3, it will be 3, and it will be 1, 2, 3, and it will be also 3. So everyone can
Yes.
speak language 3.
Yes.
Okay.
So the answer should be 2.
And should we, yeah, so like how many 3 we inserted? 1, 2,
2.
yeah, answer should be 2. Okay, now I got the answer. Answer should be 2. Okay, so what we can thinking is, okay, good question, really good question. So what we can think is 1, 4, 1, 2, 3, 4, 2, 3.
So like, can we use the connected components concept?
Yes, but we can use it. But the thing is, 1, 4 should speak a language, because we don't need to use it, because if 1 for our friend and 3 or 4 are friend, it doesn't mean that 1 and 3 has to be friends,
Yes.
and they don't need to speak the common language, right? Or do they? They don't, right? Because they're not friends. So all friends can communicate with each other. So it is not the problem of connected components, because this is not transitive.
Okay. Okay.
So it should be simpler. The solution should be simple, not very complex. The complexity is to understand the problem and formulate the solution. The coding part should be quite easy, I think. So now let's see 1 second. So let's take the second example again. And 1 for our friend, and 1 speaks 2, and 4 speaks 3. So we need to teach
3.
3. So we need to choose
Or
which.
2.
Okay, there is one answer. So we can choose all the language and teach everyone, and see how many users we need to teach, so that everyone can communicate with each other. You got it? Like we can try to teach everyone language 3 and see if everyone can communicate with each other, and how many users we need to teach. So if we use 3, so it will be 2, 3, and it will be
1, 2, 3.
3, and it is 3. So we need to teach two people. So language 3 should be taught to 2 people, and now everyone can speak to each other, right? And we can try all the language like this and see
Yes.
the least amount of effort we need to take, something like that. We can try all the language and see if we can teach it. So we can try to implement that, I think, and see.
Okay.
But it might be also that we don't need to teach anyone, right? Like they're all like, for this case, for this case, 1, 2 are friend, and 1 speaks 1, 2 speaks 2. So we need to teach either maybe 2, and then everyone can speak to each other.
Yes.
So yes, so we can implement it that way. Now how to implement it? So like we can define a function like definition number of users to teach, and we can pass the language number and it will give us the thing, the will give us. And so like for I in range of 1 to n, like minimum, like answer will be minimum of answer and I, right? And answer is first maximum, so first answer will be length of
languages.
Yes, length of languages and return answer. So now how to implement this function? Number of user to teach. So if we append one language to all the things, we just need to make sure that for every friendship we have a common language, right?
Yes, yes.
So we can implement it easily. So answer will be 0. So for we have to check every friendship and see like if they speak that language or not, if they speak a common language or not, or we have to teach them like for every friendship. So for friendship in friendships, first and second users will be friendship, and if like so we have this array and so language first will be languages first -1, right?
Yes.
Language for the first language spoken and language second, like this language spoken by the second user, it will be second. And if there is no if there is no language between them, then we have to add 1 to both, right? Like answer will be a set and we will append the user. So for language in language first, if language in language second, like we can make a small function like definition is common, language list 1, list 2, if for element in list 1, if element in list 2, then return true or return false, right? So if not is common, language first and language second. So we add both the friend in the answer dot append, and because it's a set, so it will only count the unique, so first and second. Make sense?
Yes.
Second, and we'll now return length of answer, right?
Okay.
Okay, and now let's try. Two, okay. For the first, we got
Two.
one. It should be a 2 or 1.
For the first one, it should be 1.
1. So we got the wrong answer, right?
Yeah. 1.
So okay.
So shouldn't it be just like a
Yeah, we don't need to put 2, right? We can only put 1.
yes, we have to put 1.
Yeah, because if you teach 1, but which one you should put? First one or second one?
Maybe like if we put both and like no, that won't work. So I think we should put on let's try with just putting the first one, because we have to teach only one person one language, right?
But it don't give the right answer, because if you put only 1, I mean, ideally what is happening is we should append this language to both their list. And
yes.
the second time when someone try to calculate, we don't need to do that. No, maybe we have some better answer. Let's see. It's like for this case, 2, 3, 1, 3. So 1 and 4 are friend, and 1 has 2, 3, and 4 has 3. So we don't need to do anything. Oh, first it is they have this. So okay, let's take the first example.
Okay.
Like we have 1, 2, and 1, 2, and friendships are friendships are 1, 2, 1, 3, 2, 3. So 1 and 2 has 1 and 2. So we need to teach either 2.
The first language or the second language? Yes.
Oh, sorry, no. We have
The
like
second language.
no. If the language is already present, then we don't need to teach, right? We have to check that case. Like if that language that we are going to teach, if language in language first, if not language in language first, then we need to teach.
Then we can add.
Yeah.
Yes.
And if not, because you don't need to teach if they are all they know the language already. If not language in language second, then we need to teach them. We got 1, and let's take this example. What is n? N is 3.
N is 3.
Okay, let's see. We have 2, right? Yes.
Okay.
Let's submit it.
Let's try this up.
Okay.
Really?
So the answer is correct, but we got a time limit exceed. Like we have the right approach, but we got a time limit exceed. So you have to optimize it.
Yes.
So maybe what we can do is Okay, so she'll compile it. Okay, so what we can do is like we can little bit optimize it. So what is the time complexity coming? What is language is 500. Hmm. So maybe we can improve is common function. We can put it in a hash map, and
Yes.
for every language we can create a hash map, and then we can search there.
Yes.
So what we can do is, and we can do it only once. So when we have language, so okay, language first. So like let's make lang map will be a array. So for language in languages, dictionary will be this. For alien, okay, so sorry for yes, so it's okay for alien language dictionary of L will be true, and language map dot append dictionary. So we changed into a list of map, and we can change languages to language map, right? It should work. It should work because we are using language 1, so we are language first are using. Yeah, so yeah, it should be optimized. Let's see. We're still getting to. Yes.
Yeah, it got accepted.
Great. Okay. And now how much time we have? 22 minutes.
30 minutes, 23 minutes.
Okay, let's try to solve the other question. I don't like to solve questions of permutation, but maybe it should be easier, or both are equal difficult. I don't know. Let's try.
That one is hard. Last one.
This is hard.
And last one is hard.
Hard.
Yes,
Okay.
this one is hard.
This is hard. Count ways to make product, and this is easier. But I am very weak with the XOR these things.
Yeah, this one is also complicated. Like here, we are given a encoded array, and we have to find the original array from this encoded array. And for that, how we have encoded it, like suppose here it is given, like for the ith element in the encoded string, encoded array will be the original array's ith position XOR to the original array's i+1 position.
Okay. Okay, well, just let me read the question once. Okay, so from permuted, it's easier to compute the encoded one. Like it's 1,
Yes.
3.
1 XOR 2 and 2 XOR 3. That's easy.
Okay. Okay. So, and we have to get from the encoded array, we have to get the original array.
Original.
Okay. So in the brute force, we can do one thing, like check all the permutations and see if it if you get the if it is equal to the encoded, but that will give us like
That is not possible, I think. Like we have to change each and every element.
yeah. So like I'll just write the brute force.
Oh, it is given first n positive elements.
Yeah.
Yes.
So for 1 to n, generate all permutations, and for each permutation try encode encode it and check if encoding is like
equal to the
yes
encoded.
and if it is then just output this one. But we have to be bit smarter than that. So if we have from the encoded we have to find the decoded, right? Like
Yes.
if we have 6, so 2 and 4, like let's take this example and try to like for this example. So we have 4, so 2 is XOR of, no, so 6 is XOR of 2
XOR
and
of 2 and 4.
okay,
Yes.
and 5 is XOR of
XOR of 4 and 1.
4 and 1.
4 and 1.
Okay, and 4 is
4
XOR of
is XOR of 1 and
5,
1 and 5.
and 6 is XOR of again 5 and 3, right?
5 and 3. Yes.
Okay. So from 6, can I find which are the so 6 can be XOR of 2 and 4. Also,
And
it can
5
be
and
XOR
3.
of 5 and 3. So if we find like a list of all these XOR, from there we can try to generate the original number, right? Like if you can find which are like 6 can be XOR of which combinations of numbers, from there we can try all the combinations and generate the solution, backtrack.
Okay.
Yeah, getting what I'm trying to say?
Yes.
Like 6 can be generated by 2 and 4 and 5 and 3. So you can try with 2 first, try to generate the 2, and then 5 is like 4 and 1. So 4 and 1, so you can try like 4, and then we have 4, so we have 1 and 5, so you can do it 5, and then we have 6 can be generated by 5 and 3. So we have only one possibility where you can work. Like we cannot take 4 and 2, because if we take 4 at the first element, the 2 has to be second, but 5 cannot be made with 2. So we have to make a function. Oh, this can be done. So like we have to make a function that will give us the list of this, like 2 and 4 and 5 and 3, the pairs, like for which we can get the XOR. And then we just try a backtracking and get the solution. Okay, so how much time we have?
17 minutes.
We can implement only one, and let's see the second question. In a given today array is queries. you're given a 2D integer array queries, and for each query I, where queries I is ni and ki, find the number of different ways you can place positive integers into the array of size ni such that product of the integers is ki. Okay, like let's see the example. So we have query which is 26517300 this. Okay. So 26 is like there are 4 ways to fill the array of size 2 that multiply to 6. Okay, like 1 6 2 3 3 2 and 6 ones, right? And 5 1, there's only one way to fill the array of size 5, that is multiply of 1. Okay, makes sense. And 73 66 okay, oh my god, okay, got it. How can we solve this question? And in the second case it's like this. So in the brute force, how can you solve it? And the numbers can be anything. The numbers can be integer.
Yes.
It should be like less than
Positive.
that number. Yeah.
It should be positive
Positive
integers.
integer. So okay. Positive integer. So we can think the brute force solution will be like for 1 to n, like generate all the combinations 1 to n and 1 to n till we get the answer. Like for example, the first we have to generate this array of an element, right? Like
Yes.
to be k1 k2 k3 up to kn, right? So and suppose the product is p. So let's try iterate k1 from 1 to p, then k2 to 1 to p, and whenever we get more, like whenever the product is more than p, we decrease, like also backtracking, like for k equal to 1, for k equal to k2 equal to 1 we generate it, and something like that, but that will be too complicated, I think. Or can you it like 1 6 and 6 1 can both be this? So we can try this. Like it will time out, but it will be not wrong answer by timeout. Or we can try this one, but I'm not sure how to generate this array. Like 2 4 and 5 3.
Yes.
Unless we do a brute force and try to get all the combination. Okay, let's try this question. This will be easier. Okay. So definition, generate so number. Okay. So answer will be this. So for I in range of 1 to n, right? 1 to n plus 1. First n positive number. Do you have the n? No.
Because the length of the encoded string is n-1.
Oh, so yeah, so it will be length of n, right? Yeah, n will be length of the encoded.
N will be
Okay,
length of the encoded plus 1.
1 plus 1, yes. So n will be length of encoded plus 1, and so plus 1 for j in range of 1 to n plus 1. If I j equal to number, then answer dot append I and j, right? Yes, and also yeah, so it can be, we can little bit make it bit smarter, I and j and j of I, and we can make it a set so we don't have the duplicate.
Okay.
Ij and j and I. Return answer, and now we have so so what we can do is, so for 6 we'll have 2 4 and 4 2 and 3 5 and 5 3, and we have to check for every combination, like first we will try with 2 and then we try 4 here, and whenever we get an answer then we do it. So we have to use something of backtracking. Okay, so definition backtrack, and we have at first generate all the combination. So possibilities will be this. So for number in encoded possibility dot append dot generate number, and let's print it, print possibility, and then we'll try.
So line number 37 is there is a syntax error.
Yeah.
For.
Yeah. Thanks.
So add
Yes. Position
39.
Yes. So you have 1 2 2 1 3 2 and 2 3. So for this case, so let's try 1 and 2, and we have 2 and 3. So answer can be 1
1 1 2 3.
Yeah, so answers will be like, yeah, we have 1 and 2 and we have 2 and 3. So answer can be 1 2 3. Let's try with 2 1. So we have 2 1, but there is no 1 and something like that. So we don't try it, right? So example. Also, let's try with this one. Let's see what are the possibilities we get. Okay. So we have 4 2 5 3 2 4 3 5. So if you try 4 2, we cannot go ahead because there is no 2. Now let's try 5 3. There is no 3 here, so it's not possible. Now 2 4, there is 4 1, and there is 1 5, and there is 5 3. So it can work. So we'll take this possibility. Using backtrack. It's like index and combination combination. So if index equal to length of encoded, so it is the base case, like we have this one, so return combination, or else like we'll try. So what will we try is we have index, and so and we also have the number, right? So which should be the first element, like number. So if number, if not, possibility will be we have this position, right? Yeah, possible source will be possibility index. So if, and we have to check if that number, like for example, so at first we will try with 4 2, and then we have 2, so 2 is not present here, so we cannot go ahead. Yes.
Yes.
And if it can go ahead, we have to try all the combinations. Okay. Okay, so now let's try or XOR in XOR. If XOR 0 equal to number, then we try the next index. Then we try backtrack index plus 1, and the number will be XOR 1, right? The second number.
Yes. Yes.
And combination, you have to add this number in the combination. So combination plus this XOR 0, right? Okay. This is the thing. And if you get the answer, then return the answer. So and we'll always get the answer. So backtracking will start with index 0. And okay, so for 0, we have to have a special case because we have to try all the combination, like number, or if index equal to 0, or, right? So backtracking of 0.
Yes.
Index number will be also not like it's not required, like number can be -1, because for first index we will anyway go to the second one.
Okay.
And combination will be a simple array, like this. Okay, answer will be this, print answer, return answer. Just need to debug it, it should work. 1 second, let's try the first
answer is empty.
Your
answer is empty. I think your answer is empty.
So you're not getting something, right? I think. Okay, so let's print. Okay, let's take the first example, 3 and 1, and let's try to print something and try to debug it. Okay, print Okay, so first we have index is 0, -1, and this. And we try with the first one. So we have 1, 2, and 1. And then we have, okay, so when we have 2, 3.
We so in the like the breaking condition, we should input the number then, like where line number 43.
Yes, what we should input?
Should we add that number to the combination?
Yes. Uh, Combinations, yes. So combinations, number, and index is what? Index is 2, right? So when index is 0, 1, 2, then we should -1, right? Let's see. No, 1 second. So in when it is 2 and 3, index is 2. So index is 2, number is 3. Okay, so I need to maybe send index 0, not no, we are sending 0 index, right? So 0, 1, 2. And no, I think, so what is happening is, 1 second. At first index is 0 and number we are passing is -1, so it's the base case. So in the base case,
Yes.
it will try with 1, and then we will get now index 1, and then we get number 2. So number 2 is present. So we have index 2 and number 3 and this array. So when we have index 2 and 3 is present, right? 3 is present here. So we should get 2, 3, and 1 and 2. So we should get, one more thing, right? Index. So when we have index 2, so 0, 1. 1 second. Maybe we need to go one more. So when it is 2, index is 2 and number is 3, and 3 is present. So when we have this, we should, okay, XOR is positive. No. There is one simple case that I'm missing. Like in this case of 2 and 3, let's see this case. When we have index is 2, number is 3, and combinations is 1 and 2.
Yes.
And so index and length of encoded equal to, I think we cannot return this number. It won't work. Maybe we can have a global array, the global like self answer equal to -1, like self dot answer will be this, and don't return it, and we just return and print self dot answer and return. Like we have a global variable where we return it, because the return won't work in case of backtracking. Yeah, so you see 1, 2, 3, right? It's working fine. And let's try this one. It will give you, I think, timeout, but let's try it. But we get right answer. Okay. So I think we need to optimize. Let's start out. We need to optimize this generate. This one. It will take n squared time, but maybe this will pass. So let's try to submit it. Okay, so our answer is correct. We just need to optimize it, right?
Yes.
Timeout, we get timeout. So let's try to optimize the. So let's see the time complexity that we are getting. I think this is taking n squared time, right? It is time n square into n cube time, right? Generate. And we have, yeah, so how much time it is taking? N square, right? And n is odd. So can you optimize this one? Because it is taking n cube time. So it is not optimized. So I have one solution that we can do, like for every I and j, we don't need to, we can do it only once. Like, I mean, we can have a position like, okay, let's optimize it. Okay, so for I in the I this and j in this, position, so XOR will be I XOR j, right? And position XOR -1 will be, it will be a set, and dot add ing, like we're just doing it only once. Does it make sense? J and I, like we are trying all the combinations of I and j and putting it there. So we got XOR, and do you think it's right? This one, the index, or it should be only XOR? Yeah, it should be XOR -1, I think, yeah. Because XOR is position of. Okay, let's try to print the position first, and let's see if we optimized it or not. So run the code. Where you got the error? Line 19. Okay, sorry. So let's see, we should get the same answer before. So at first it was generated number, and if we get this number, we add I and j and I, right? But we can optimize it for all the number, right? For number in this encoded, for number in this encoded position. Oh, sorry, it's already ended. But let's solve it. Are you here, Saurabh? Mm-hmm. Are you here? Hmm. So I am saying that earlier we are doing generate, right? Generate number, but we can optimize it by doing it only once. Like for I equal to this and this equal to this, and if I and j is all equal to this,
Okay.
and okay, but we don't need to so if zor is less than length of encoded, then we can do this, right? Make sense?
Yes.
And let's see if both are equal or not. Position this, and second position will be this. Append, and we just put a set here. Let's see both are same or not. No, both are not same, right? I mean, nj and I.
Less than
Equal to, I think. Four five, 4 2. Once again, so what do you think is the, like I'm just trying to optimize it, generate number. So for number in encoded, we are generating this number, right? And now I'm trying to do it for all, and zor equal to I and j, and if zor is less, so second second position no. Can you figure out what is something wrong? So for position, for number in the encoded, position append. So we're generating all the combinations which can give the zor, right? Like answer equal to set for I in the range of 1 to n plus 1, j in the range of 1 to n plus 1. If I and j are more like zor is number, we append answer this one and this one, and we return the answer. And I want to do it in a single loop, like because this will be in a combination. Do you think something might go wrong. Anyway, it is end the competition, so we could solve one question. Let's take the 3-1. Maybe we can figure it out if it is a small input case. 3 and 1. Okay, in case of 3-1, we get 1-2-2-1 and 3-2-2-3. But in case of this, we are getting 3-2-2-3. Okay, so I think we have to do like it's okay. I'm lost right now, but we could solve one question. So I need to solve one question. So let's stop here. Are you there?
Oh, yes, sir.
Yes. So and you can try it back home. Like my brain is not working right now. So let's just stop here. Anyway, bye.
Bye, sir.